Good. Okay, so let's continue our tour through the planets. So today we're going to do it a little bit differently because now we're hitting these kinds of planets. Do you guys remember? So the last 4 planets we talked about were the terrestrials. What do we call these 4 planets together? What are these? What kinds of planets? Yes. These are the Jovian planets. So today we're going to start talking about the Jovian planets. And what makes this a little bit different than last time is that we're going to talk about Jupiter and Saturn at the same time. We're kind of hitting a crunch here. I'm going to try to, fit as much material in to this semester as we can without overloading you guys. But Jupiter and Saturn are so similar that we can save time by talking about them at the same time. So, unless I say otherwise, everything I'm about to tell you guys applies to both planets. Okay? And you can see why we would talk about Jupiter and Saturn together. And then next time we're going to talk about Uranus and Neptune together, because Jupiter and Saturn look much more similar to each other than they do to these 2 planets, and they look similar to each other. So let's start off by taking a look inside of the planets. Okay. Oh wait, I've got a huge echo. Are you guys getting weird audio? Let me know if you guys are getting weird audio. Oh no, somebody was just having something weird running. Okay, good. Sorry about that. All right. Now, here we go. Let's talk about these. We're going to go inside the planets. So let me go to the next slide. Now, where we go? There we go. Okay, now, one thing here. Even though this is a diagram for Jupiter, the layers inside of Saturn are the same as the layers inside of Jupiter, but the sizes are slightly different. So I'm going to go through the layers on this diagram for Jupiter, but it's the same layers for Saturn. I'll show you a slide in a little bit that shows you the slight differences between them. Okay, now, if we look down here, way down here, this is the Earth with all of its layers that we talked about for comparison right here. So you can see just how much bigger Jupiter is than us. And I want to label these layers slightly different than how they're labeling them here, okay? So this very middle part right here, let's just call this the rocky core, okay? We're going to call it the rocky core. It's made of the same types of material as in the Earth, but the extreme pressure of everything else sitting on top of it turns that entire core solid, okay? So there's no liquid metal inside of that rocky core like we have in the inside of Earth. And I wanted to point out something here. Which one of these is bigger, the Earth or the rocky core of Jupiter here? What's bigger? Is Earth bigger or is the core of Jupiter bigger? Yes, that's correct. That's correct. The core of Jupiter is bigger than the Earth. So it probably has at least a little bit more rocky material than we have. But remember, it's still mostly liquid and gas because the rest of this, from here all the way up, is all liquid and gas. Okay? Now, Jupiter's very, 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 very big, and you'll notice that all of the other layers here are labeled with hydrogen. And that's because the only things that there's enough of to make something this large in the universe is hydrogen and one other element. And they're not listing that here, and I don't like that. There should be one other element mixed in with this hydrogen and helium. Can you guys figure out what that second element would be? Hydrogen's the most abundant thing in the universe. There's only one other element that there could be enough of to fill up an ocean and atmosphere this large. Helium. That is correct. That is correct. So here's how I want to label these layers, okay? Check this out. This one right here, that it's labeled metallic hydrogen, this word right here is going to confuse a lot of you guys. Because when you think metallic, do you typically think solid or liquid? When you think of metallic things, do you typically think solid or liquid? Usually. Right. But if you've been paying attention, you normally think of solid when you think metallic, right? But if you've been paying attention to what I've been saying, this is an ocean. So is this metallic liquid or solid? This metallic hydrogen right here. Yes, this is a liquid. So how I would like to label this layer right here, instead of just metallic hydrogen, is liquid metallic hydrogen and helium, okay? So down here we have our rocky core, and then we have liquid metallic hydrogen and helium. And then right here, this should say liquid hydrogen and helium, and then gaseous hydrogen and helium. So for all of these, I want you to add and helium to these three layers, and for this one, add the word liquid in front of it. Okay, so from here down to here is all of the ocean, but part of the ocean has this extra word metallic on it. Now, what does that mean? I kind of wish we would use a different word than this, because when we say metallic hydrogen, we're talking about hydrogen that has one thing in common with metals, okay? And that's that it can conduct electricity, okay? So regular liquid hydrogen can't conduct electricity, but liquid metallic hydrogen can, okay? So when you say liquid metallic hydrogen, you really just mean liquid conductive hydrogen, okay? And how do you make liquid metallic hydrogen? It's pretty simple. You just take regular liquid hydrogen and you squeeze it really hard. So if you take regular liquid hydrogen, like we can just make without too much difficulty, and squeeze it extremely hard, it makes it so it can conduct electricity. It turns it into liquid metallic hydrogen. So, here's my question. What does Jupiter use to squeeze all of this liquid hydrogen here and turn it into metallic hydrogen? How does Jupiter squeeze this hydrogen? Yeah, so the pressure on the hydrogen is just coming from gravity. And what can we tell about the gravity of Jupiter based on the fact that most of the liquid hydrogen has turned metallic? What can we tell about the gravity of Jupiter? If gravity is what's turning this liquid hydrogen metallic, what can we tell about the gravity of Jupiter based on the fact that most of it is turned metallic? That is correct. That is correct. The gravity on Jupiter must be very high. And that makes sense with what we've said about Jupiter before. Jupiter has a very high gravity because its mass is so high. Okay? Now, up here on top, this gaseous hydrogen and helium, that's the atmosphere. And you can again see that the width of the atmosphere here is about half the width of Earth on Jupiter here, but you could drop a lot of Earths into this ocean. Okay, now that's the inside of Jupiter. Is everybody good? I'm assuming everybody's good so far. So what is different about the layers on Saturn? Okay, let me show you this picture right here. So again, we got this is Jupiter, this is Saturn. We've got our rocky core, our liquid metallic hydrogen and helium, our regular liquid helium and, liquid hydrogen and helium, and our atmosphere right here. Over here on Saturn, we have the exact same 4 layers, but there's one that is a lot smaller on Saturn than on Jupiter. Which layer does Saturn have a lot less of? So it's the same 4 layers, but Saturn has a lot less of one of those layers. Which one? Let's figure that out. Pop it in the chat. That is correct. That is correct. We're getting a lot less liquid metallic hydrogen. So it still has a very deep ocean, but more of the liquid hydrogen is regular, less of it is metallic. So what does that tell us about Saturn? Why would Saturn have less liquid metallic hydrogen inside? That is correct. That is correct. There is less gravity on Saturn. Okay? So basically, the interior levels of Jupiter and Saturn are the same, but because Jupiter has a higher gravity, it has more metallic hydrogen in its ocean. Okay. Now, I'm almost done talking about the inside of these planets, but there's one last thing I want to talk about, and that is magnetic fields. Okay, I'm going to just hit this very briefly. Remember, Earth has a magnetic field because we have something inside of our planet that can conduct electricity. Let's see if you guys remember. Do you remember what substance inside of Earth conducts electricity and gives us our magnetic field? How does Earth make its magnetic field? Uses a type of liquid metal. You guys remember what it was? Liquid iron. That is correct. Liquid iron is what gives Earth its magnetic field. Okay? Let me go back to this slide real quick. Does Jupiter have liquid iron down here in this core? Does Jupiter have liquid iron to make a magnetic field with? That is correct. It does not. Remember, what's the pressure like down here? Remember, there's so much weight crushing down on this core that it's probably mostly solid. So there's no liquid iron to make a magnetic field with. So here's the next question. Does Jupiter and Saturn have a magnetic field? Do those guys have magnetic fields? To help you answer that question, remember, to have a magnetic field, you have to have a liquid conductor inside. Okay? And while you guys are answering that question, somebody had a question, is there iron? There is still iron in this core. It's just solid. Everything's solid in here. So does Jupiter and Saturn have a magnetic field? Ooh, you guys are a little bit scared here. Okay, so you guys let me trick you. You let me trick you. Jupiter and Saturn do have a magnetic field. It just doesn't come from liquid iron. Remember, to have a magnetic field, you just need some kind of liquid that can conduct electricity in there. Is there a liquid in this planet that can conduct electricity? Yes. What is it? It's the metallic hydrogen. That is correct. So Jupiter and Saturn make their magnetic fields with this liquid metallic hydrogen. Okay? Earth makes it with this liquid iron down here in its core. Jupiter and Saturn make it with this liquid metallic hydrogen. So here's my next question. Would we expect Jupiter and Saturn to have a stronger or weaker magnetic field than Earth? Are Jupiter and Saturn stronger magnetic fields or weaker magnetic fields than Earth? Stronger. That does make sense. It does make sense that they would be stronger because they have a lot more conductor in there that they're spinning up with the same convection that I talked about in the magnetic field video. So review that. Now, final question about this magnetic field. If we look back at this picture, Jupiter and Saturn have the strongest magnetic fields in the solar system for the planets, of the planets. Which one probably has a stronger magnetic field? So which planet is the number one strongest magnetic field in the solar system based on everything that we're saying so far? Yes. Yes, you guys are getting it. You guys are getting it. Because Jupiter has a much larger amount of liquid metallic hydrogen, it's going to have the number one strongest magnetic field in the solar system. Saturn is number 2. Okay, so Jupiter has the strongest magnetic field. Saturn is number 2. Now, there's one last thing I want to say about a magnetic field. Remember, our magnetic field protects us from the solar wind of the sun. But every once in a while, some of that solar wind will trickle in at the weak points at the poles of the Earth. And when that solar wind hits the atmosphere, it causes something. Do you guys remember what happens in the sky when the solar wind hits our atmosphere at the poles? Yes, that's what makes the aurora, right? So as long as you have a magnetic field and an atmosphere to hit, you're going to have an aurora. So Jupiter and Saturn here do have aurorae, okay? They do have them. However, they look a little different. Let me show you a picture of an aurora happening on Jupiter. Okay, so this is a picture of basically the northern lights, or the aurora, happening up here on the North Pole of Jupiter. I like this picture. I think it looks pretty cool. Does this look exactly like our auroras? No. What's different about this aurora compared to the auroras on Earth? I think I have a picture of it back here. Here's our auroras right here, right? Yeah, the color is different, right? The color is different. Can you guys figure out why the color of the aurora would be different on Jupiter and Saturn? So Jupiter and Saturn would both have this sort of neon blue color. Why would the color be different on Jupiter and Saturn? It's a different gas. That's correct. If you remember, these gases light up based on their fingerprint, and every type of element and molecule has a different fingerprint. So Earth, remember, has an atmosphere made out of nitrogen and oxygen. And as a couple of you guys are saying, the atmosphere here is mostly made out of hydrogen and helium for both Jupiter and Saturn. So that's why it lights up a different color. Different gas, different color when you light up.